So the goal for this was going to be that you should be able to graph any function that looks like a cosecant bx plus c plus d, or a secant bx plus c plus d. Right, so by the end of this, you should know how to graph either function. We're going to graph one period of these functions, just like we did with sine and cosine. And since you guys prefer sine over cosine, we'll start with cosecant, because cosecant is like the related function to sine. So first I want to remind us that cosecant of x is just 1 over sine x. So when graphing cosecant, we're going to be using sine quite a bit. So let's just graph just the parent function cosecant of x. In order to do this, first graph sine x. Right? So you kind of ignore the fact that we're talking about cosecants, and you graph the related function first. So since sine is related to cosecant, we're just going to graph sine x first. And we'll do that the way we have been doing it. So like the period is 2 pi divided by b, or here that's just 2 pi. The interval is 0 less than or equal to x less than or equal to 2 pi. So our interval is from 0 to 2 pi. Our interval over 4, that's just our period divided by 4, or pi halves, which again tells you what the x-axis is, how you're going to make marks on the x-axis. Okay, amplitude is 1. And then the midline is 0. And we can use all this info to then graph sine. So we'll start at 0. We're going by pi halves to get to 2 pi. And it has an amplitude of 1. And I'm going to graph this using a dotted line. And remember, positive sign has this pattern right here that we use. So I'm going to graph it using a dotted line, and you'll see why in a moment. So we'll graph that dotted line for the sine function. And so far we haven't graphed cosecant at all. Now we can start graphing cosecant. So what we want is dotted lines where the graph intersects the midline. So wherever you see your graph intersect the midline, so here we're looking like wherever sine intersects the midline, and the midline's just that x-axis, we're going to make dotted lines up and down. And these are called asymptotes. And there's one also on 0, but that's just the y-axis. Okay, so that's the first step to graphing cosecant after you've graphed sine. And then second, you're going to basically be drawing parabolas at the tops and bottoms. And I'll just leave it as that because you'll understand what I mean when you see it done. But you'll start at the top here of the sine function, and you're making a parabola that goes up towards the dotted lines, or up towards those asymptotes. And then down here, it'll go down towards those asymptotes. So that the graph of the cosecant function is just those parabola-looking parts. All those dotted lines are just to help us graph cosecant. So really the only hard part for graphing cosecant, or secant for that matter, is graphing the sine or cosine that's associated with it. All right, any questions on this so far? So these parabola parts, this is the cosecant of x. Okay. Let's look at a less trivial example than the parent function. Let's do 2 cosecant x plus pi quarters. So again, when you're graphing cosecant, really what you do is you start by graphing sine. So instead we're going to graph, I should have said graph here. So instead we're going to start by graphing y equals 2 sine x plus pi quarters. Alright, so we'll start 2 pi over b is just 2 pi. The interval is we're setting the argument of sine between 0 and 2 pi, and you're solving for x. So like we need to subtract pi quarters from each spot. So our interval is going to be negative pi quarters to 3 pi quarters. Sorry, not 3 pi quarters, that would be 7 pi quarters. Then the interval divided by 4, that's going to be your period over 4, which is pi halves. Amplitude is 2. And the midline, let's make this interesting, let's add a midline to it. Midline is equal to 1. Alright, and then we're going to graph the sine function. And we're starting at negative pi over 4, and then we're adding pi halves each time. So the next spot's going to be pi over 4, and then add pi halves to get 3 pi over 4, and add pi halves again, 5 pi over 4, and then we'll finish at 7 pi over 4. All right, and this is all stuff that we did with graphing sine and cosine. The midline is at 1, so we'll draw a nice midline there at 1. And then it's a positive sine function, so it's going to follow that positive sine pattern where you start at the midline, go up the amplitude, back to the midline, down the amplitude, back to the midline. So we're going to use that to graph sine. So we'll start at the midline here, and then we'll go up the amplitude. The amplitude is 2, so we're going to go up 2 from the midline, back to the midline, down 2, back to the midline. And we're going to make a dotted sine function because this isn't actually the graph of cosecant. We're just going to use it to graph cosecant. And then wherever you see the sine function intersect the midline, you're going to make vertical asymptotes, vertical bars up and down. So like it touches the midline right here, touches the midline right here, and right here. And then finally, you're ready to graph the cosecant part. The cosecant, you're just starting at the peak or the bottom of the sine wave, and you're making parabolas towards the midline. Or not towards the midline, away from the midline. Towards the asymptotes on the side. So those parabola parts are the cosecant function.